Hey, what's up, guys? So here we are back again. Really apologize. The microphone scene here is not very loud, I guess. So apologize if the mic is like really quiet, if it's coming through really soft on your end. Maybe like myself in a YouTube presentation 2.0, I'll get a better mic. But I do have this like microphone here, so just trying to show it something. I don't know. So I'm trying, guys. So, anyways, so let's get back to it. Um, so where were we? So like we were asking Cursor to basically modify our dashboard here. So like I'm in Cursor in the agents window here, um, and yeah, so I haven't checked it out. So like the last prompt that I did that was pretty big. It didn't take very long for Cursor to. So I ended the last YouTube video, and then I um, just that huge monster prompt here. I bet it only sat and worked for maybe less than 5 minutes. Not very long at all. So this is okay. So it did make a couple more HTML files. Um, and let's just try and run it. So I see a couple different HTML files. So like what we have going on here is like all of our data behind the scenes is in CSV format, not coming from a database. This is just like very uh, analyst workflows. So like um, the analyst library here, pandas, they do actually have some kind of like dashboarding abilities. Same thing with analysts that use the programming language called R. There is also a web app that R analysts can serve, little dashboards and everything. So it's not too common. I mean, it's not that out of the ordinary for an analyst to serve some really basic web app dashboard. Though I'm not going to use Dash. Dash is something for Python. I'm going to use more of like a generic web app. Maybe I'll use Flask or something in a little bit, but just for now, I'm just using something that's built into Python for web app testing purposes. Okay, so one other thing I was thinking about while I was had some downtime in between this video and the last video, and just like economizer diagnostics, like since this data set is mostly geared towards a full spring of tail end of winter and the beginning of summer, like we have the full envelope of a shoulder season. So typical retro commissioning, the really good projects that I've seen in the past, like there would be a peak heating season, peak economizing season, where you test economizing, mixing dampers, free cooling, sequencing on airside systems, um, and then also a peak cooling season. So usually three things in a really good retro commissioning project or data analysis. And we can focus on one of them here because we have a complete shoulder season data set here. So we chatted about that a little bit before. So then I just asked ChatGPT to query the internet for the economizer diagnostics. I've seen a couple really cool webinars out there specifically for economizer diagnostics in the past, and it can get very mechanical, engineering theory based, mostly on mixing air streams together from a return air to a supply air, a mixing air, outside air, so that's kind of the meat and potatoes, blending air streams, not using mechanical cooling. And it did come up with a few things from PNNL. I know that PNNL is really good building retuning stuff. It's probably a good 10 years old by now. So I made a prompt for Cursor to kind of dump all this into our little web app here too. So let's see what it looks like. I have no idea what is going to come out, what'll happen here. What do we have here? We'll see. Not really sure. Economizer should be enabled dry bulb. True, when outside air is cool enough compared to the return air temperature and there's a cooling load. Makes sense. Outside air fraction, that's the mixing equation to get the percentage of outside air. And ultimately we just want to be watching binning outside air temperature data of how many hours of mechanical cooling is running when we should in theory be trying to use free cooling. I don't see that here, but maybe we can ask her that next. So pretty big prompt. Like when you ask, sometimes I ask ChatGPT to make a prompt for me, and it'll just create these enormous prompts. I think this is getting into a little bit of like loop engineering, like the latest and greatest thing in AI. Instead of prompt engineering, it's loop engineering. So like, wow, this is actually really a lot bigger than I thought. So like what you're asking the AI agents to do behind the scenes is do a ton of work. It's not just one task, it's many tasks. So that's a loop. Wow, this is a massive prompt. So sometimes I think AI is really good at prompting other AI. Cool. Okay, so then another thing I asked it to do too, I thought of research on HVAC sensor faults because I think that the expression rule library falls short a little bit on changes per hour and sensor ranges for both an imperial and metric for typical HVAC sensors. So, like for example, you should never see a zone temp sensor go so many acceptable changes per hour. Usually, a zone temp sensor is pretty stable, even if it's fluctuating wildly outside and it's not getting correct cooling. The sensor should not have some acceptable allowable changes per hour. But if you're looking at a sensor that's the leaving air temp of a cooling compressor, or a chiller that's like a chiller that's staging itself, so like those sensors will be a boiler firing, will be wildly changing, values per hour. But there's other sensors that should not change a whole lot. So that's something we do in fault detection. I'd say the meat and potatoes of it is just basic sensor validation that this sensor is it's reading legitimate values that you would see for that appropriate application. It's not flatlined. And then it also has a sensor range bounds. Sometimes in building automation, the building automation technicians, if the zone falls below, in an occupied building below 68 degrees Fahrenheit or above 80, whatever, that's a building automation alarm. So that's comfort ranges, but then in fault detection algorithms, we can do more of, this is a bad sensor kind of a range. It shouldn't be reading anything like that. So, and it should be caught on the building automation system alarming, but half the time what happens in building automation systems is the building automation alarm console turns into the little boy that cries wolf, that there's so many alarms happening, people just ignore it. Very often, more than likely, I would bet on making money that most buildings have an alarm console that's been neglected. It hasn't been maintained. I would bet heavily, and that is usually the norm, that the building alarm console is just it's a service. It's something that requires active servicing. If you want to have a really good maintenance team, if you wanted to kind of score like how well do they monitor these HVAC systems, immediately if they tend to the alarm console, that's a very high indication that they're a really good maintenance team. That's just my opinion. So that's if they're tending to the alarm console, they're more than likely tending to belts and filters, sounds in the HVAC system. They probably not monkeying with set points. They shouldn't be. So you have alarm consoles. Okay, so I asked ChatGPT to comb the internet for research papers, whatever, mechanical engineering theory. For example, a parts per million, measuring CO2 in a return airstream or in a zone should never go below 350 and above 1200. Makes sense. And theoretically you shouldn't unless you're on a submarine. Then you're probably pushing into the 2,000 or 3,000 or something like that. Okay, so some of these get kind of a little bit out of the range. There's also like some there's some hobbyist framework for weather stations. I need to get into this and buy their book. I haven't read it for a while, but there's a weather station, hobbyist weather station, nerd kind of stuff. They even have acceptable changes per hour in your hobby weather station, in typically ranges like this. There'd be like a really good like electronics hobby. I would love to do that. Is make one into BACnet. If there's a person that is a weather station nerd, they're probably pretty good for fault detection diagnostics and HVAC systems. Okay, so cooling coils. Some of this you need to filter for when the fans are running, so we'll probably see that in the data. This looks pretty good. So I also filter differential pressure, building pressure, so duct static pressure. So these are variable volume systems. Wow, that is 8 inches of 8 inches water column of ductwork, isn't it? Or 8 inches water column is an insane amount of duct static pressure. You're like blowing up that steel duct like a balloon, and I don't think maybe at the discharge of a fan, where you both have static pressure and the pressure that's like, so there's two kinds of pressure, like static and velocity pressure, I think. Building pressure is an important one too. Some of the laboratory systems that I used to work at when I was Johnson Controls technician, where I spent most of my time in research labs, we used to have to work with a building before we would sign over the building to for it to be occupied. I would work with a test and balancing contractor in case the makeup air system failed, that the research exhaust systems, we would have an allowable pressure differential between doors so people could escape. If there's a fire, the exhaust system's still running, the makeup air unit quit. It's definitely some allowable ranges there that these sensors need to be in calibration. Filter differential pressure, which could vary wildly in loading of filters, dirty filters. Then COVID has a whole new thing about this too. So like filtering for MERV, whatever rating of the filters. Look at valve positions, 105 to 5. That is not that good. It should be 0 and 100%. So we might have to have that changed. So this did get updated into the expression wheel cookbook. So we should have this built into our application. So when I ask Cursor to fire up our little app here, a very important thing, like not only in energy saving fault detection measures, it's just a small component, but we also have sensors and input output that is failed on the HVAC control system. So let's check it out. Okay, so I'm just gonna ask Cursor agents, so please fire up the dev server in Python so I can review the dashboard. So what goes on behind the scenes, it should be opening up PowerShell right here. Look at all this data. We don't even have to look at it anymore. AI agents, just, they should be handling it for us, as far as I can tell. Okay, so here we go. So it's on localhost 8000. So I'm just gonna copy, open external browser. Oh wow. Okay, so what do we have here now? All right, so now we're just gonna keep on refining, keep on keeping on. Okay, so what do we have? So overview. We've got some buttons. I like buttons. Charts are a little bit hard to know what's going on here. So I see mechanical cooling, spring economizer, and heating end of heating season, weather stations, fault flag. Looks like there's a couple of faults being thrown. So it's cool. Like Plotly, like I was saying, is like you can zoom in and it is throwing a sensor fault. So let's just like look at some of this data. The only thing I don't see is, oh, okay. So it only did air handling unit 1, open media. So that's our web weather. Wow. So that's a big fault right here. So look at here. This could just be a flatline sensor though. Sometimes it's hard to tell, like if it's actually good data. This chart looks really mashed together. Well, this is better. So like I can tell like these faults. So fan run hours, springtime run hours, mechanical cooling. These are faults. Fault condition 9, 10, 11, 12. Huh. Overview. Oh boy. When I asked for it to wow me, okay, what is this? Red line. Cumulative excess. I don't know what this is. I think it's what it's trying to do is it's trying to show fan run hours per week that are outside of the range that that the client says that they need to operate the building. So they said 502. Okay, so like this is the occupied building. So the occupied building is from 6 a.m. to 5 p.m. and then Saturdays 7 to 1400, which is 2, closed on Sundays. So I think this is an accumulation of excess runtime. It's really confusing though. Okay, so like we'll get okay, so we have to start having it refined. I just don't know where to start. Percentage of occupied zone samples in band. The shade of bands mark the 3 seasons of functionality for two things. Air handling, mechanical. Cooling's active when economy should handle the load. And 2, the chiller compressor running when outside air temperature is less than 55. Wow. Okay, I don't get this. It's 2. Can you revise main tab? The chart is something I don't understand. Please make these individual items easier to read. Make more charts. One for each ECM. Weekly free cooling opportunities. Available mechanical cooling hours this week. Double click. Okay, so. Alright, so I'm going to say the following chart about mechanical cooling hours. We need to adjust this into a bin hour type of chart for bins of outside air temperature values and mechanical cooling is running. Get out of here. I did actually write an article on LinkedIn about this. So I wrote, let me just see, articles. Okay, this one. So this is an article about simple HVAC analytics for school districts. And I was doing this for with SQL and getting data with normal framework. So I am going to maybe I could just feed it this link. We need these kind of charts on that article. On this article, please revise for Python. I'm just going to dump it all in. Okay, so get rid of you. Also, the chart titles are mashed with the legends, and I cannot read the text. Please fix everywhere in general. Data note. All right, it is a little bit better. So, okay, let's check out zone and comfort. Percentage of occupied zone and samples. Yeah, I don't get this. Season average percent of occupied hours between 70 and 74. So we do have some like the lowest ranking VAV box. Lowest comfort. Percentage of occupied hours within 72 degrees with a 2-degree tolerance. So apparently these guys are the worst. Good to know. So this could be something where if you were in a retro commission project that you have to fix a percentage of the or you don't have to fix, you have to visually test a percentage of the building. You can actually, some data like this, you could zero in on, let's go physically look at these boxes and stroke all the dampers, make sure the reheat valves goes back and forth, like visually put eyes on it. So we do like those. Worst zones detailed. Wow, average temp during occupied hours. So this looks fine. I do kind of like this. End of heating season, VAV 22. So this looks good. Okay, so I'm gonna say on zones tab, the worst case is good. I think you could just dump this right into Excel too. If you right click and copy the charts for lowest comfort is good. For ranking, I'm going to say please revise the monthly average. So I have no idea what this is trying to depict. Floor comfort by season. I'm going to say just remove that one and rank, and do a rank per season on which floors maintain zone temperature best for the chart. And then this one should be and revise this one to be not percentage of time, but actual degrees Fahrenheit, where a line represents each floor from averaged VAV box zone temp data. Okay, next, outside air weather station data. I don't know what to think of this. They do kind of track each other. In general, open media is way lower. Open media is lower, at least on air handling unit 2, air handling unit 1. So basically, if the outside air temp sensor reads higher than what it actually is outside, so pretty common. So let's say here. So if it's, what do we have here? So we have 43 degrees from the weather station at the airport, and then 50 degrees at the local building sensor. So I think what'll happen is the control systems will start cycling the boiler off sooner and mechanical cooling on sooner as well. So like, I think in general you would see more mechanical cooling at lower levels than you need it because the sensors for the outside air are off and they're high than what it is in theory. So people would be running the chiller premature. So I should save that in our prompt here. Okay, so I'm just gonna say that up here. Please make our bin data based off of the weather station data from Open-FDD and not the local sensors because they appear to be off. Okay, temperature delta histogram. BAS minus outside air temperature data. I have to think about this. So this is this guy right here is a histogram. So all of the data. So the BAS minus open media sensor data. I think this is showing, if I'm interpreting this chart correctly, that this is actually kind of interesting. We need to remove outliers. Histogram. Remove all outliers. But I think that this is representing is that through statistics you can see on average that if 0 is like open media, air handling unit 1 or no 2 reads this is like kind of think of it as like a percentage warmer than the web weather station. So the air handling unit 1, just by this histogram, I think appears to be more uniform. Like you want the data to be normal distribution. So if it's off like by some scale continuously, I think like this is what the air handling unit 1 would represent. But like when this is all shifted to the right like this, I think we would see generally that this air handling unit 2 outside air temperature sensor is way would read way warmer. Let's just see if we can see something as a general trend. This might be really hard to spot. I think like what's also going on here too is there's flatlined instances here where maybe we're not getting very good data. What you can kind of see that is that the weather station dips like way lower. So you see the green line that represents the actual building automation sensor is this right here, this gap in between here is like what this histogram represents. So kind of cool, I guess. So faults by hours, end of heating season, mechanical cooling season, outside defined season. So okay, so air handling unit 2, outside air temperature sensor is much more problematic compared to air handling unit 1. You can see that in the histogram too. So cool. So this is cool too. Air handling unit 1 mean absolute value is 2.9, and the mean absolute value of air handling unit 2 is much bigger. So like I think what they're doing is they're subtracting these two values from the they're taking this difference between the two values, and then you roll that across the entire data set, and then that's how you get the mean absolute value. So like what I'm also seeing in this too is that in the winter that this sensor is much more off than it is during mechanical cooling season, but we might just have more data. I think it would be interesting too if you could even box it into like morning, afternoon, twilight hours. That you would be able to see in the afternoons the sun shines on the sensor, and that's why that it is off during that particular time of day. So it happens all the time. Is the building automation system? The installers have a install it in a poor location. So like the electricians are always supposed to install the outside air temperature sensor in the shade on the north side of the building, and sometimes they have to cheat, and you can't get that wire stretched all the way from one end to the building to the next. That it's just hard to do in some buildings. And always by design, the outside air temperature sensor is hardwired to the boiler plant, and then it's shared across the building automation system as a networked value. And they do that because if the network goes down inside of the building, the local area network or the BACnet MSTP trunk or something, that at least the boiler will be able to heat. And they've always been doing that for very common traditional practices. Yeah, so very important sensor. So I thought this is good. This is good. Keep this. Keep this. It is good. Please, I need to say, sometimes I say there's bonus points if you can yield something in this chart for time of day. In addition to show time of day for sensor error. But then it would make a difference if it's cloudy or not cloudy. So, okay, so air handling units 1 and 2. Oh boy, so what do we have here? So, we're not showing, okay, so before I get into this, I'm going to ask, please show all fault equations for each AHU and put FC1, that's guideline 36, fault equation 1 for the duct static pressure control of the variable fan on its own chart, and all other temperature related faults can be on a separate chart. I'm not seeing, okay, mix air damper position. Okay. Hopefully it'll figure out that fault condition 1 chart, we're just looking at, this is MAD, mixer damper percentage. That we'll just be looking at supply fan speed outputs and duct static pressure and inches water column. This percentage, say don't mix units on same axes if possible, and faults on a pool on a separate pool axis. Okay, so no, I just want to say put all faults in here, please. We should be doing everything except FC6, I think, that requires design airflows. Make a fan run hours column for weekends and weekdays as well. All right, economizer free cooling. Available mechanical cooling. Still have a hard time what it's trying to depict here. So I'm going to say for this one, please make a plot of mechanical cooling in hours and some accumulation of when the outside air dew point is below 60 and the dry bulb is below 72 degree F. We should make a bool flag for this as our high limit based off of the open media weather sensors. I have a feeling there's a lot of other stuff we have to just dial back because those charts don't make much sense to me. But some other project I have seen for algorithms in optimization is instead of we just did something really simple like for economizer enable logic. Like you can do something based on enthalpy, return air enthalpy versus outside air enthalpy. And we went off of outside air dew point, partly because the systems we were working with were really old and ancient, and some of them didn't have return air humidity sensors. And anything that's outside of like what the manufacturer recommends of like just a couple years maybe, you probably may not want to leave return air enthalpy control just because it requires calibration. So like we went off of a weather web station dew point where if the outside air dew point is below 60, which is pretty safe, and then the dry bulb is below 72 as a high limit, we were calling that as a free cooling is available. Maybe someday we could do like a deeper dive on that, on what it looks like on a psychometric chart. But basically, in shoulder seasons, when the air is relatively dry, the dew point is very low. So, like, as long as the dew point is very low, which anything below 60 is low, very low. And then as long as that dry bulb doesn't increase below like a zone comfort, 72 degree dry bulb, we can 100% outside air, into the building. So, gosh, if there's something in here that. Okay, so it made chiller 2. Okay, I'm gonna say make the daily hours available of free cooling based off of this. Please revise that chart. I have no idea what this is supposed to be doing, but we can probably revise that later. Maybe look at that later too. And I'm gonna say please provide a chart of weekly runtimes for each chiller, daily hours, bin, and time series. All right, so let's I think I'm going to let it run here, and then let's come back in just a couple minutes and then see what it looks like. Be right back. All right, so here we are back again. Looks like cursor is still thinking. So economizer diagnostics. Now we'll just have to go a little bit into this in more detail. Wow. Economizer sensor fault. I don't know how it came up with this stuff, but maybe we can. Some of this stuff we just might have to just tell it to get it out of here because this is too much information. Or we'll just have to tell it to dial it back because this is too complicated. Free cooling summary. Weekly free cooling opportunity. This seems kind of redundant from what we looked at before. Oh, there is a chiller hours here. Makes sense. So like they are running their chillers a little bit in March and April. March is really cold for upper Midwest to be running the chiller. Sometimes you don't have to bring them on until May if you're lucky. So like these are just in theories we could be doing much more free cooling as possible. Then obviously as you get up to here, you're definitely doing much more mechanical cooling. So this, I do like this chart. This is about the only thing like okay, so excess fan runtime. All right, I think we're getting somewhere, guys. So like it's daily excess runtime. I think they said that these air handling units start at the same time. So like this is something that in theory, a mechanical engineer can use this data to calculate like an energy saving strategy. So like if we knew how much electrical consumption in kW that this system pulls, the system, draws, which is constantly varying though, you can apply some kind of a calculation. Okay, so I'm just going to ask it to redeploy the dashboard, please. Looks like it was finished by the time I could even go back here. Ooh, shoot, I know what I wanted to ask for. I took some notes. So I wanted to also ask, so let's do these ones here too. I'm going to say one more thing and then another refresh on the dashboards. Ooh, I don't know if we'll be able to do this. Can you make an adjustable fault tune parameter, slider, or input box and refresh button for each plot or page? And then is it possible to have an input text for notes? I'm going to say, for example, I am the analyst and want to make notes and then package this dashboard to be sent to my client. So then they can deploy and see the settings that I tuned the faults, and then with notes from me in the dashboard. I'm going to also say feel free to use Flask or some easy Pi web framework for this modification. So this might be actually kind of like a big lift. So like what we were doing before is like this is making code in the pandas library in Python to Plotly pandas. So now we're gonna ask the AI agent to morph this into a web app for us, so that we can take notes and refresh and tune our parameters and everything. So this is actually a big lift that it would take the human. It would probably be belly aching if you asked your web app developer to, I need this input. They'd be like, oh my god, I'll come back in a week. But it looks like, yeah, look at cursor actually is spinning up like all these to-do tasks here. You can also say, also we need this to be something sanitized that we can zip up and package to Google Drive and then download as a read-only dashboard on the cloud, on some cloud interface, I guess. So we should ask it to do that too. Well, I wonder if this is enough to just stop it for here. But this stuff is pretty cool. I think we're getting somewhere. I did I was kind of thinking that that this would be a 6-video process. So we're on video 4 right now, and I think I was thinking about 6 hours. We're still on target. I think I probably spent I would say an hour if this work was billable, and just I would say 2. So like 2 hours of working with the client's API and downloading the data. And they had a really good API where the AI agent could just, make all these scripts, and then I could in Python and just download bulk data basically from their, where they hosted, and how I can obtain the data as an analyst. So I didn't include any making those videos. So I think I'm up to about 6 hours deep into this. So, and I think like traditionally, this would probably be a 60-hour ordeal, where I think like with all this AI agents helping us to do all those type of things, like cut that back by a whole order of magnitude. So I think like a 60-hour estimate could get down to 6, especially if you know what you're doing and you have like good tools to work with and everything. And then what I wanted to do too is, once we have something working for the building 100, is I'm just going to ask it to duplicate it for the building 50, because they're actually kind of redundant systems. They're the same systems. They're 2 air handling units, variable volume with VAVs on each floor, same kind of chiller plant, same kind of boiler plant. So I'm kind of lucky here, is I can ask the AI agents to just duplicate it. So we'll have that. I'm kind of wondering if this could be part of so like another thing that I'm like we're doing here too, I think it's worth mentioning that like we're asking AI to maintain all the HTML, all these web apps. So it's something that I've also noticed on YouTube, is that the AI YouTubers mostly are tasking the AI to maintain the dashboard. So I think that's exactly what I'm doing here, is like I'm asking AI to write all the code, and I'm definitely asking it to maintain it too. So like something very popular in this joke on YouTube, I think, is like people are saying, I wouldn't want to maintain that HTML, so I'm right there with them. I wouldn't want to do this either. So like that is a huge heavy lift we don't have to do. Gosh, I'm just debating. Maybe I will ask the client if they want to have this hosted on, have this dashboard hosted on like some kind of cloud interface, because there is like some, just keeping in track. So like cursor agents have, looks like they've buttered up all the code. Sometimes I do play around with free web hosting services. So I know something I could do right now is Python anywhere. Python anywhere. So this is a hosting service that's been around for years. I've had a free tier forever, which I have played around with. $0 a month. So you can probably get away with deploying something like this on a free tier. little bit of storage there, so we'll just have to see if we're under 512 megabytes of data and hosting this little web app. We could definitely do this for free. Host our little dashboard from Python Anywhere, and then anywhere around the world, someone could dial into it. Render is also another service too. Render web apps. So this one isn't too bad either. Like I could even have, like if this was a client that was paying you to write reports on a regular basis, I would probably use Render or either one of them. You could be any web app hosting service, and you just refresh your dashboard once a month or once a quarter or something like that. And Render would be a really easy one too, because you could just link it right to GitHub. So curious if anyone wants any help with this. I'm available for freelance. I would help you understand, how to deploy web apps in Vibe code, assuming you're an analyst and you know about HVAC. Like how to deploy this yourself, do all the legwork. So don't hesitate to look me up. And then I'm also available for hire too if you have a bunch of this kind of work and you need assistance, like your team can't keep up or something like that. I'm more than happy to assist on some kind of hourly rate. I love this kind of stuff, so I could almost do it as a hobby. So I kind of believe I think once this is kind of dialed in, what I want to do is sample of an agentic AI software engineering spec. So this is the final goal of this. Let's just see what Google said. So this is where I want to go with this. So I said 6 hours of videos here. Tomorrow will be video 5. And then the last video, hopefully I can squeeze this all in, is that we could write a software engineering spec for what we did. And then in theory, it could work with any AI agent framework, any data set. I'm not using a data model here. If I'm doing weekly one-off stuff, if I'm using someone else's API for this job and another person's API for this job, really random one-off stuff, I probably wouldn't use a data model. But if I just had one job of running one big database, if I worked for one company, one service, I probably would use a data model. But I think for this one-off stuff, assuming the data would be exactly the same every time you get it, I don't know if a data model would help me very much, as long as I can know the feeds relationships. So most important thing is what air handling unit serves what VAV box, that kind of thing. If you can get that, the rest is just an assumption that there's one chiller plant and all air handling units have the same chilled water from that source or boiler plant. Yeah, so I think that's about it. Let me know if you guys have any questions or interests, or if I'm glossing over something a little bit more, not enough in detail. But I could almost turn this into another GitHub project too, for just some generic example on vibe coding dashboards for fault detection diagnostics, and and it's completely free. If you consider Open-FDD Fault Framework Expression Rule Cookbook is completely free. The only thing we are paying for is the AI tooling. So like I pay a little bit of a service fee per month to use Cursor and ChatGPT. So, but it's way cheaper than probably using some proprietary tool or something that already exists. You just have to put a lot more elbow grease into it to do it yourself. But with AI agents, like this stuff should get easier, faster, better, almost free. So that's where I'm going with this, guys. So thanks for your time today. Let's keep on pushing Cursor a little bit more, a little bit more. I might even do a teeny bit offline the video camera, and I'll show you what I just pushing Cursor into like more of a finalized project for video 5 and then video 6, just to be on target that this is just to deploy it on the web somewhere. And it just is an example of like how you could deploy it for your client, and then just have them dial into it, and then with your notes, and then or you could even have them download all the code, all of the CSV data, and they could even host it on their own IT framework. So that's assuming that you could work with their IT department, that their IT department could just host a little dashboard internally on their corporate networks or whatever. And they could even run cybersecurity scans across these files, like if they want to validate that all this like little piddly web app code, analyst code, is safe. They can do that with scanning tools for security. So there's a bunch of different options. Kind of curious, like, what you guys think. I'll be back tomorrow, so hopefully maybe we could even finish it up tomorrow. This is fun stuff. So like, I do have some ideas. We could probably keep continuing with this too. I have an old electrical metering. It's a school that had a big mechanical retrofit about 10 years ago, actually. So, but I still have the data from it. So it's just an electrical meter. And then we could vibe code using Open-FDD, and then do some really basic fault detection rules across the electrical meter data, and then maybe even some measurement and verification, if I can remember, in the data when the project had the retrofit. It's been a while, but so I have some stuff like that too to play around with. So, and then it would be kind of interesting just keeping track of like hours. So like, how much time does it take to do all this stuff? And then this agentic AI vibe coding specification, how to we'll make this like easy, better, faster. So like, there's lots of contexts that we can give to the AI agent to hit the ground running and have like full-blown dashboards and results very fast, nearly free. So, okay guys, thanks for your time, and I'll catch you on video 5 and hopefully video 6 tomorrow.